Hello. So yeah, my name is John Pacific. I'm a cryptographic engineer at NuCypher. So to go over briefly what NuCypher is, we're essentially a blockchain privacy layer for decentralized applications and blockchain applications. We are building something that is very similar to a key management system. If you're familiar with like something like AWS KMS or Google Cloud KMS. But except we use something a little different. We use proxy re-encryption, which is a form of public key encryption to decentralize this application. So this is going to be a bit more of a technical talk with a demo at the end to explain what this is. So proxy re-encryption is essentially a new form, not a new form, but a more recent form of public key encryption, where I'm sure everyone's familiar with it with the Alice-Bob narrative, where Alice will encrypt something with Bob's public key, and Bob can decrypt it with his private key. Proxy re-encryption introduces a third party as a proxy in this scenario, where instead of encrypting for Bob directly, Alice can encrypt for herself, pass along a re-encryption key to a proxy, and Bob can have that data re-encrypted for himself so he can decrypt it with his own private key through this proxy, which uses a re-encryption key. So we'll go into a centralized form of it first, and then a decentralized version of that. So essentially, Alice would essentially encrypt it with her public key, the data, and then pass along a re-encryption key that she generates to this proxy. Now, when Bob wants access to this data, he goes to the proxy and asks for access. If Alice has said that he can have access, then Bob can simply send this encrypted ciphertext, which was originally encrypted for Alice, to be encrypted for himself. So the proxy uses this re-encryption key, re-encrypts the data, and the ciphertext out, Bob can decrypt with his own private key. We take this a step further. We've implemented a crypto system by a cryptographer named David Nunez, who has just recently joined the NuCypher team. So essentially what we do is we take a threshold cryptography system that similar to like a Shamir secret sharing. We apply this to the re-encryption key, where we generate fragments of this re-encryption key and pass them along to a number of nodes, where we have a threshold M of n. M is the minimum number of re-encryptions to get the data back, and n is the total number of k-frags, or re-encryption fragments, that you distribute to the network. So in the NuCypher network, we have plenty of these nodes, and you can choose any number of them to send these re-encryption key fragments to. When Bob wants access, he goes to each node and gets this data re-encrypted. When he finally performs the minimum number of re-encryptions, then he can actually have access to the data. So this is useful in many cases. For example, a decentralized marketplace like Datum, or decentralized databases like Blue-Zell and Fluence and Volk, who use this for an access control layer. Medical data sharing companies such as Mediblock, Metachain, IRYO, they're using this to grant the data owner access and control over their data. So you don't have to share this data unnecessarily with, say, a hospital or a doctor, and you can revoke access whenever you need. This is essentially a very, relies upon the cryptography of proxy re-encryption to do this. And we're very happy to be one of the first consumer and enterprise grade key management systems that actually allows us to get this done, especially in the Ethereum network. So to dive into a little bit of what Umbral is, Umbral is Spanish for threshold. So that essentially relies on the threshold cryptographic part, very similar to Shamir secret sharing, as I referred to earlier. If you're a cryptographer, you'll be happy to know the following. Umbral is unidirectional, single hop, and non-interactive, meaning that you don't have to share your private key with the re-encrypting parties. It's unidirectional, meaning it only goes in one direction, and that Bob cannot decrypt or Alice cannot decrypt Bob's data for simply generating the key. And single hop, meaning that it can only go from one party, and that's it. We built it using a KEM-DEM approach, which essentially allows us to use key encapsulation, which is Umbral itself, and data encapsulation, which is something like Cha-Cha-20, Poly 1305, or AES 256. It is IND, PRE, CCA secure. That's a security definition where if you're a cryptographer, that's what you care about. It was defined by Susan Honenberger and another name that has left me in 2007. We also can do verification of this re-encryption that it was actually done correctly through non-interactive zero-knowledge proofs. Our code is available on our GitHub, and we also have documentation there as well. So feel free to come on there, check us out, and also look into this. So now we're going to skip into a demo real quick. All right, so I'm going to demonstrate our proxy re-encryption library to everybody now. First, let's import the library. This is all done in Python, by the way, so if you have a Python terminal, you can actually download our code and make this happen right now. So this is actually going to fail since I had to do it for the demo already. So when I try to set a default curve again, it doesn't let you, but I'm just going to do it for demonstration purposes. So next, let's just skip straight to key generation. We're going to generate a public key and a private key for both Alice and Bob. And in our scenario, Alice has data she wants to share with Bob, but doesn't want to actually encrypt this with Bob's key every single time. So she simply encrypts the string. Proxy re-encryption is cool. And she gets a ciphertext and an Umbral capsule. An Umbral capsule is the output of our key encapsulation mechanism, which is the Umbral crypto system itself. You can think of it as an encrypted key. And she does this by using Alice's public key, her own public key, the plain text, and we print out the ciphertext here. So next, just to show you, Alice can decrypt this data with her own private key. She passes in a ciphertext, the encrypted key, the Umbral capsule, her own private key, and a public key to sort of verify a signature. This decrypts. Proxy re-encryption is cool. Next, we're simulating Bob receiving this Umbral capsule, this encrypted key, through a side channel, such as maybe IPFS along with the data. This re-encryption doesn't need to happen on the data itself. It can happen on the key. So you only have to re-encrypt 100 bytes only 100 bytes. You don't have to encrypt or re-encrypt gigabytes of data. So next, Bob hasn't been granted access yet. It has not been re-encrypted. So when he tries to decrypt it, it fails. So now we're going to grant Bob access by having Alice generate key fragments. She creates 10 of 20, that's that M of N number, where she generates 20 re-encryption keys, fragments, and distributes them to the network, where Bob only needs 10 re-encryptions to be performed to actually have access to the data. So Ursula then re-encrypts this. Ursula is the name for our proxy, this third party in our network. So she's going to generate, she's going to receive these K fragments, and Bob has to go to each independent node and have re-encryption performed. I'm simulating it here by picking 10 random fragments and then performing this re-encryption. Bob would attach them to his capsule, as you can see there, and then when it's ready, he can decrypt it. So as you see here, Bob was granted access using this exact capsule by attaching the re-encrypted C fragments. When he attaches the C fragments, he can decrypt it with his own private key, which allows him to get access to the data even though it wasn't originally encrypted for him. This is essentially what is powering the NuCypher network. Again, you can come to our GitHub and check it out. We welcome everyone to come take a look at our code and participate in our developer discussions. As well, if you know anybody who has a problem like they need to store public data or store private data on a public chain such as IPFS or even a centralized service such as S3, they should be using NuCypher. So if you have this problem, please come talk to us. We would love to hear it. Thank you.